In this section of the lecture, we learn how to find the equation of the plane in the Cartesian form and in the vector form when the 3 points are given to us. Now, firstly, what is the equation of plane in the Cartesian form? For example, 3 points which are given as x1, y1, z1, x2, y2, z2 and x3, y3 and z3. These 3 points are given to us and we have to find the equation of plane. The equation of plane is in this form: x minus x1, y minus y1, z minus z1, then x2 minus x1, similarly y2 minus y1, z2 minus z1 and x3 minus x1, similarly y3 minus y1 and z3 minus z1. This is the equation of the plane in the Cartesian form. When you derive the equation of plane in the Cartesian form, then you have to convert this equation in the vector form. I will tell you one by one by taking an example, and then I also convert this equation of Cartesian form then to vector form. Now, for example, the 3 points which are given to us are, and we have to find the equation is, for example, we have 3 points, 3 comma minus 1 comma 2, and the next 3 points which are given to us 5, 2 and 4, and next 3 points they are minus 1 and 6, and we have to find the equation of the plane. Now this is x1, y1, z1, this is x2, y2, z2 and similarly. So in place of x1 what we write? 3. In place of y1 we write minus 1. Then in place of z1 we write 2. Okay. Now x2 minus x1, this is x2, that is 5 minus 3. 5 minus 3. Now here we get y2, that is 2 minus 1. Similarly 4 minus 2. Now x3, what is the value of x3? The value of x3 is what? Minus 1. Minus 1, minus 3. Similarly for y3, for y3 we have minus 1, y1 that is minus 1. Now z3 we have 6 and z1 we have minus 3. If we watch carefully, we can observe that all the minus 3 are there, all the minus 1 same. Okay, when you practice you can do it easily. Now this remains as it becomes y plus 1, and here 5 minus 3, when we solve, what does it become? It becomes 2. Here it becomes 2 plus 1, that is 3. Here it becomes 2. And now here it becomes minus 4. Now plus minus 1, that is 0. And it becomes 4. Okay. So in this way we got a determinant type of. Now when we solve we get x minus 3. Now 3 4s are 12 minus 0. Then we put a minus sign over here. Then y plus 1 and 2 4s are 8 minus 2 4s are 8. Then z minus 2 and 2 into 0, that is 0, plus 4 3s are 12. Now we solve this equation, we get 12 x minus 3 minus 8 and 8 16, y plus 1, similarly 12 z minus 2 is equal to 0. Now we solve this equation and ultimately we get the equation of the plane for these 3 points. Now see how we solve that. we multiply it, we get 12x minus 36, then minus 16y minus 16, then plus 12z minus 24, which is equal to 0. This is the Cartesian form of the equation of the plane. Now 12x minus 16y plus 12z minus 36 minus 16 minus 24 is equal to 0. When we add, what we get? 6, 4, 10, 16, 3, 1, 4, 1, 5, 2, 7, 76. That is 12x minus 16y plus 12z minus 76 is equal to 0. We divide it by 4. 4 3s are 12, 4 4s are 16, 4 3s are 12, 4 1s are 4, 4 9s are 36. So this is ultimately the equation of the plane in the Cartesian form of equation into vector form. So vector form is equal to r dot n is equal to t. So we just write simply r dot, in place of x, y, z we write I, j and k. X for I, y for j and z for k. That is 3i minus 4j plus 3k, and this 90 d vector we write over here 90. So this is the vector form of vector equation of the plane. Clear? So it's very simple. In order to write the equation of the plane in Cartesian form or in vector form.